Hello good people, I'm going to continue talking about scientific notation. I'm going to demonstrate conversions from normal to scientific and from scientific to normal. The first value of 4,735,000 has four significant figures. These significant figures will make up the coefficient. The decimal point is placed after the first digit, in this case the 4, and so we have 4.375. The magnitude is a base 10 power, and so I can already write multiplied by 10. I need the exponent. What is the place value of the leftmost digit, in this case the 4? It is in the million position. To determine the base 10 power for a million, I'm going to count how many times the invisible decimal point at the end of the value has moved. It has moved once, twice, 3 times, 4 times, 5 times, 6 times. Therefore, the scientific notation is 4.375 multiplied by 10 to the power of 6. I'm going to repeat the process for the value 2070. It has 3 significant figures, and they will be part of the coefficient 207. The decimal will go after the first digit, so I will have 2.07. I'm going to multiply it by 10, and I'm going to count how many times has the decimal point moved. Once, twice, 3 times. So the scientific notation is 2.07 multiplied by 10 to the power of 3. In case of 13,000, we have 2 significant figures, and they will be part of the coefficient. The decimal point goes after the first digit, and so we will have 1.3. I can already multiply by 10. I need the exponent. How many times has the decimal point moved? Once, twice, 3 times, 4 times. So the scientific notation is 1.3 multiplied by 10 to the power of 4. The next value is 0.060. It has 2 significant figures, and these 2 significant figures will make up the coefficient, which means I will have 6 and 0, and the decimal point goes after the first digit. I need to multiply by 10 because I'm constructing scientific notation, and now I'm going to say to myself, watch out, this value is less than 1, therefore the exponent will be negative. And then I'm going to count how many times has the decimal point moved. Once, twice, and therefore the scientific notation is 6.0 multiplied by 10 to the power of negative 2. The next value of 0.0093 also has 2 significant figures. They are going to be part of the coefficient, so I'm going to write 9.3 multiplied by 10. The value is less than 1. I can write negative for the exponent, and now I'm going to count how many times has the decimal point moved, and it has moved 3 times. So the scientific notation is 9.3 multiplied by 10 to the power of negative 3. The last example in this list has 3 significant figures. As before, they will be part of the coefficient, and the decimal point will go after the first digit. I'm going to multiply by 10. The exponent will be negative because the value is less than 1. And now I'm going to count how many times has the decimal point actually moved. And in this case, it has moved 5 times. Keep in mind, when going from normal to scientific notation, the coefficient has to contain all of the significant figures, whereas the magnitude gives the place value of the leftmost digit. Let's go the other way around. Let's go from scientific to normal notation. The starting value is 3.072 multiplied by 10 to the power of 5. The first step is to write out all of the significant figures that are in the coefficient. So we will have 3072. The magnitude of 10 to the power of 5 is the same as 100,000. So it is telling me that this 3 is in the 100,000 position. Right now, it is in a 3,000 position, which means I need to write placeholder zeros until this 3 is in the 100,000 position. By adding 1 zero, this 3 is in the 10,000 position, and by adding a second 0, this 3 is now in the 100,000 position. The second given value is 1.04 multiplied by 10 to the power of 3. Once again, I'm going to firstly write out the significant figures from the coefficient, and then I'm going to take the magnitude into account. 10 to the power of 3 is the same as 1,000. This is telling me that this one needs to be in the 1,000 position. Right now, it is in the 100 position. So I'm going to write an additional 0 at the end, and that will make this one occupy the 1,000 position. The next value is 7 multiplied by 10 to the power of 2. Alright, I'm going to write the 7. It is the only significant figure present in the coefficient. And now I'm going to consider the magnitude. 10 to the power of 2 stands for 100, which means this 7 needs to be in the 100th position. Currently, it is in the 1's position. By writing 1, 0, the 7 will end up in the 10th position. By adding another 0, the 7 will end up in the correct 100th position. The value 2.1 multiplied by 10 to the negative 1. What will that be in normal notation? The exponent of the magnitude is negative. This means this value is going to be less than 1. And so I can already write 0 point. The magnitude of 10 to the power of 1 is the same as 1 divided by 10, or a tenth. It is telling me that this 2 needs to be in the 10th position. An alternative way to approach this is to read this exponent as a guide to how many zeros you should have. It says negative 1, therefore I should have 1, 0. I have already written it. All I need to do now is write the rest of the coefficient. And so my value in normal notation is 0.21. What about the value 3.67 multiplied by 10 to the negative 3? The exponent of the magnitude is negative. This means that in normal notation, this value is less than 1, and so I can write 0 point. 10 to the power of negative 3 is same as 1 divided by 10 to the power of 3, or 1 divided by 1,000, which is 1,000th. So this is telling me that this 3 needs to be in the 1,000th position. Alternatively, this negative 3 is also telling me how many zeros I should have. I have already written 1, so I'm going to add 2 more, and then I'm going to write out the digits in the coefficient. 3, 6, 7. And so 3.67 multiplied by 10 to the power of negative 3 in normal notation is expressed as 0.00367. Let's deal with the last example in this series. We have 9.601 multiplied by 10 to the power of negative 5. The negative exponent of the magnitude is telling me this value is less than 1, and so I'm going to write 0 point. Now I'm just going to use the shortcut. The negative 5 is telling me that I need to have 5 zeros. I have already written 1. Let me write the other 4. Once that is done, I write the digits from the coefficient. 9, 6, 0, 1. If all else fails, you can actually use your calculator. Let me quickly demonstrate. So we have 9.601, and then to write the magnitude, I'm going to use this times 10 to the x button. I'm going to press that, and I'm going to tell the calculator that the magnitude is negative 5. Once I press the equal button, it will give me the normal notation. That is all for now, and I will see you on the flip side.